Okay, we will be solving the first basic numerical that is given on page number 15. Okay, I'll write down. Let a period of revolution of a planet at a distance r from a star be t. Prove that if it was at a distance of 2r from the star, its period of revolution will be root 8t. Now, what is given to us, we should see what is given to us and what we need to conclude. Then only we will be able to interpret which law we can use. So basically, since time is involved, period is involved, and the distance is involved, we have to bring in Kepler's law. And I think it will be Kepler's third law. Kepler's third law is that the time period, the square of the time period, is proportional to the cube of the distance. I think that is the law. That is t square is proportional to r cube. Okay, let me check if there is any error in that. No, there is no error as such. So now planets and stars, whatever celestial bodies, will follow Kepler's third law. Now okay, I will just give you all a rough description. Consider this as a rough elliptical orbit. The period of revolution of a planet at a distance r from a star bt. The sun and the moon are also called as stars. So let this be a star. Let this be some planet. Okay, I'll represent the planet as P. I'll represent the star as S. Now the distance is R. And please keep in mind this is an ellipse. So distance will be changing every time. But the R is taken to be the mean distance. And I have already discussed what is the mean distance. Time period is T. So in this case it will be T square is proportional to R cube. Constant we need to introduce, so T square will be equal to kr cube. I will call this as my equation 1. Now they have given a condition. Prove that if it was at a distance of 2r from the star. Now I will draw another ellipse. Somewhat a bigger ellipse. My figures are not up to scale, these are just rough diagrams. And now if it was at a distance of 2r. Again, if it is a mean distance, consider this as planet P and star S. Its period of revolution will be what? Time period now it is given as question mark. That we need to find. Now see equation 1. K will be equal to T square upon R cube. Now consider the second case. In the second case also, this is an elliptical orbit. So it will follow again the Kepler's law. Now what is the trick involved here is that the constant will be the same. So then we can conclude what is the time period. So I will consider this time period as something T dash of this new one. T dash means it is not the same as the time period of the first one. Is proportional, square is proportional to, now this r is replaced by 2r because this distance is 2r. 2r the whole cube. So I need to remove the proportionality sign, so I will introduce a constant is equals to k times. Now what is 2 cube is 8. And what is r cube? R cube will be r cube. 2r cube is equals to 8r cube. The cube of 2r is equals to 8r cube. Okay. So then k will be the same. Therefore k will be t1 square upon 8r cube. Call this as equation 2 and equation 3. Now from equation 2 and 3, what do we get? t1 square upon 8r cube is equals to t square upon r cube. If there is any error here, now we need to find the time period of revolution. So the time period of revolution is t1. t1 square, take 8r cube this way, so it will be t square upon r cube into 8r cube. R cube will cancel, r cube will cancel, and it will give me 8 times t square, t1 square. Now this is the square of the period of revolution. No, t1 is a new time period. So when I take root, taking square root on both sides, I'll call this as equation 4 of equation short form EQN of equation 4. We get t1 will be, now what is the square root of 8? Square root of 8, okay, it will come somewhere, okay. So I will take it as directly as 2 root 2 it should come. 8 and square root of t square will be t. So that is the answer. Okay, square root of 8 no is equals to square root of 4 into 2, and when 4 comes out of the square root it becomes 2 root 2. Okay, but you can directly express it in this form. So this is our numerical, that is the fourth numerical given on page number 15. You need to see what is the requirement, what is the data given, and which law can be utilized. It's very simple.